Pocket money kits seems to be one of the favourites of Merg, especially for beginners. And most of them have started life as solving a problem. They haven't come out of my head because I thought it was a good idea, apart from a few cases. It's more that people have said, I wish we could do that, or couldn't we do the other? And we've tried to work out a solution. And that's where this shuttle came from. I'm pretty sure you all know how the shuttle works. It's a very simple circuit. It's a very well-known circuit. And it's been in the journal as a pocket money kit for going on, what would that be, almost 8 years. So it's based on a well-tried technology, a 555 timer chip. And the timer just switches itself off and on a regular period, and that in turn switches the relay on periodically, off and on. And every time it switches the relay off and on, the track power reverses and the local goes back and forward. Very, very simple. That's sold pretty well. Usually found very handy on club layouts because there's always something happening in the background, even while you're busy setting up locos for the public to look at. So there's 6 members at the fiddle yard at the back setting up stuff and nothing at the front. At least the shuttle's going to go back and forward to keep interest. And that was the main purpose for bringing it out. But recently one of the members from here today said, well, it uses a capacitor and resistor, charging up the capacitor, discharging it, charging it, discharging it, to switch the relay off and on. And depending the values you pick, depends how long it's on, how long it's off. And they wanted to have more control because it's fixed just now at approximately 30-second period. And we said, well, what you can do there is just change the values of the capacitor and or resistor, and that will make it faster or slower. And that seemed like a satisfactory solution at the time. Then the same person came back to me, didn't you, and said, right, I've built it and that's fine. I've put lights at either side, or how would I put lights at either side? So when the train's going to come out, it'll turn to green for them. Otherwise it's red. And the initial option was to say, well, just put in either a bipolar LED at each end or a couple of LEDs, one red, one green, reverse wired. So when the power's one way, the red will be on at the top, but the green will be on the other side and vice versa. Went away and did that and came back and said that works, except that when the locals say going leftwards, the green light's on the whole journey time. And the same coming back, the other one comes on green the whole journey time. What I want to happen is both lights are at red, then one will switch to green, and when that happens, the local comes out, and after a period, both lights go back to red. And for most of the journey, both lights are at red. And we can't do it with that circuit. And then that led to me thinking, well, can we solve 2 of them at one time? Because that's the same basic setup. I've taken the word 555 out and said, if I put a microchip PIC in there, they can do the same switching of the relay as a 555 does. But we don't have to rely on capacitors and resistors to do it. We can actually write some code that would give us more control. And then things just sort of snowball from there. As it stands, to make it work as a shuttle, all we do is switch the relay, wait till the train gets to the other side, into the isolated section. It'll sit there for a period, and then the relay will switch. It'll come back out, go their way into the other isolated section, and sit there for a period. And that's all it does, and repeats and repeats. Now, how it waits for the 555 is just capacitors, resistors, hardware. If we use a programmed chip, we can decide how long it waits in software. So that was the first thing that I looked at. There we go. If we put a PIC chip, we can put a little trimmer resistor there. And on the right hand side, we connect the trimmer. It reads the value, and as you adjust the trimmer setting, we can use that to say how long you wait at each end. In other words, how long is the total journey time between here and there and getting back again. On the left hand side of the chip, we've got an output to drive the relay. I've used a resistor there because, a transistor there, sorry, because the relay takes too much current to be driven direct from the PIC. So we replaced the 555 with a PIC. We've added two other components, and now we have complete control over the journey time. The journey time can be set in that circuit you're looking at, anything up to 255 seconds. From 0 to 255 seconds. Now there's 4 minutes odds. You need a very big layout, even in Lisa's garden layout, to take you 4 minutes to get from one end to the other. But it gives it's not taking 4 minutes to get from A to B. The maximum time would be to get to A and B and stay sitting in the siding for a while. You don't want the loco to be continually going back and forward. You soon burn out your motor, overheat it and so on. You want it to go to one end, sit for a period of time, and then traverse back, sit for a period of time. So that's got to be included in the delay that was set with that trimmer. So solved number one, the journey time has been solved. But I've got a PIC with lots of pins on it, so we can use that to solve the second one that we've been asked about signals. So we want to have signals placed in a position where it's after you come out the isolated section, and once it passes that point, the light should go back to red. And I want it to be able to handle either light signals, in other words LEDs, or a semaphore arm, depending on the period. So it should have the semaphore arm go up and down rather than changing from red to green. So we have to handle both those possibilities from this PIC. So there's the two options from the one pin. It's been arranged that everything to do with the left-hand side of the layout comes out the left-hand side of the chip, and everything to do with the right-hand side of the layout comes out the right-hand side. So if I now take like pin 10 you see in this circuit, and we take it to two LEDs, one going up to the plus 5 volts, one going to the 0 volts. Then all we need to do is change the state of that pin 10. If pin 10, for example, went to down low to 0 volts, you've now got a 5 volt potential across that green LED, and it will light up. Whereas the red LED has got 0 volts either side of it. There's no potential difference, it won't light up. Similarly, if pin 10, so we only need to use one output pin to change the two different LEDs. If you want to have semaphore arms operated by either a solenoid, but more likely a servo, they can take pin 10 in the bottom diagram, come straight out of the PIC chip, straight into whatever servo controller you're using. Easy points, servo 4, the servo 1 that's coming out, something like that, with just one wire, assuming you have a common 0 for all your modules, which you would do. We've managed now to have the hardware to do it, and all we need to do is work out the coding. I discussed the coding for this project at the JAL Special Interest Group, and I won't cover it here. Just look at how it works here. That's actually been recorded. If you want to see the coding behind this, you can actually go into the national website and you'll find it in there as a video. So we've got ourselves now, we're able to control the delay of the journey, and also the switch the lights or semaphore. Now we could have done that by saying after you want to switch the power to go leftwards, wait 3 seconds or wait 5 seconds, whatever, and then we'll change the signals. But we want more control over that, because you might be building a little demonstration layout that's only 3 feet long. And in 3 seconds or 5 seconds, you've gone from one end to the other. Or you could be building it on a 40-foot U-shaped layout that one of the clubs has. And you want longer than 3 seconds. In other words, you want control not only over the journey time, but how long it takes before you switch from green back to red. Well, that's fair enough. You just do the same. Again, we now just add a second trimmer. So the top one is the journey time for the shuttle, and the bottom one is after the train starts to move, how long do you wait before you put the signal back to stop or to red, whatever. And we now have pins 10 going to the signals before, and pin 5 going to the left-hand side. And that's it. We've now got the 2 main questions that people ask. Can I control journey time, and can I control lights? So far, so good. But if you look, there's still lots of pins that are not in use. So why stop there? And then decided, well, maybe we ought to have an option rather than using a trimmer, because if you've got a layout, you might decide to put in that siding you've got isolated a single local, a single tram, for talk's sake. Or you might have a whole train, and you might change them around. So you want to have some more flexibility. So why not have track detectors? And you space them at a point that once it passes the detector, that's when you change to red. So now the user has the option of just using a screwdriver to set the trimmer, or fit 2 totties, and it's completely automatic, and it's regardless of how long your train is. And the LDR totty just consists of a light-dependent resistor and the resistor, and you put 5 volts across it. The idea being that the resistance of that light detector varies depending on the amount of light that shines on it. So if we go to the junction where the LDR meets the resistor, you see a wire going away with an arrow on it. That value is going to change depending on the amount of light. In the LDR totty, we use that to switch a transistor. We don't need that here because we've got a PIC that can do the exact same job. So by adding 2 components at one side and 2 more at the other, we can now make this shuttle do the job of 2 LDR detectors. There we go. We've put the 10K on the board itself, and where you see the red dot and the white dot below it, you simply connect your LDR either side. And we're now back to the software. How do we jump between having it tweaked by a screwdriver compared to using totties? That's your choice. And there's a wire link you'll see that gives you the option. You can put a wire link in, you're using one option. With a link out, you're using the other option. With a link out, you're using the trimmer to set the preset time. If you put the link in, it depends on the train coming out hitting the totty. In some respects, the totty is an extra advantage in that if you have it as a preset time and the train's in the siding and it's due to come out and doesn't move, and I'm sure that's happened to quite a few stiction, you've got to give it a little touch with your finger to move it. By that time, the lights have changed to red because it's a preset time. If you use totties, they'll stay at green forever until you actually get the train moving. So you can overcome any stiction. So it's got an operational advantage, you like, at the price of a couple of extra components. Good, that's something extra we've added, but there's still spare pins. So why stop there? That's why we call it Shuttle Plus. I was thinking of a name for it. Why not control the points? Andy Willis was talking earlier about the auto changer for the shuttle. And it's a kit that we make already, and it controls a points controller. So that locals can traverse back and forward, back and forward, back and forward, and points keep changing automatically. Why not embed that inside this pocket money kit? We still need the points controllers. You can't do everything. You still need to have an easy point or a server 4 to operate the points, but we can control it now with this circuit. At the end of the journey, time goes into one siding and stops. We can switch points, so a different train comes out next. So we get variety. We have two locos that keep traversing back and forward. A goes there, B goes there, A comes back, B goes back. So every time you look, it's not the same train going back and forward. It's different trains. We can do that with the spare pins. As simple as that, the red dots and the black dot below it. The black dot is the common zero voltage on this module, but it's also the same common zero voltage you'll find on your easy points or your server 4 or whatever. So we only need one connection between like pin 9 there to one easy point, and that's you moving the point in one side. Pin 6 can connect to another easy point on the other side, and it's switching the other point. So we now control the journey time, we control the switching time for the lights either automatically or manually, and we now control the point movement. But there's still spare pins, so we can add some more functionality. Why not? Now I built it to test it. Right, and this started off life as an article for the journal, and it was suggested to me that it should be beefed up and become a kit in its own right. But that's what I used to test that the system worked. Right? And that's what it looked like when it was built. I've added a few more components since then to get more functionality. But you can see there's hardly any parts to it, really. You'll see it a bit better in a moment. Because we're short of space, that we wouldn't happen in a PCB, we've had to have wires that pop in at various holes on the layout. Not very satisfactory, but it kept it down to a price and didn't involve a PCB. There we're getting much closer to what it should look like. You can see now most of the pins are used up. We've got the totties coming in, the points going out, the signals coming out, the options link, the various trimmers. If you do a component count, there's still not an awful lot of components, but we do have a couple of extra outputs, which I've put question marks on, and we've called them auxiliary 1 and auxiliary 2. And what that means is you can do what you want with them. And the idea is that they trigger once the loco is safely in translated section, before the train comes back out again. So for example, one of those could be used to operate a sequencer. The loco comes into one of the sidings and all kind of activities and sound and lights happen. Or it could be crossing gates in the middle. So while the trains are sitting at the siding at either side, crossing gates can open and close and then carry on. Aux 1 and Aux 2. I've added in some of the bits like the capacitors, the idiot diode, the diode across the relay for protection and so on. That's a complete circuit now. So there's a possible use for it. We've got the PIC operating the relay. We've got the pink dots to the left and right with the yellow centres. That's your totties coming in. We're operating the purple blocks either side are the point motors. There's your lights. In the middle, I've got a couple of crossing barriers, and down the bottom I've added one of the auxiliaries going to a sound player. So what we can have is the train comes into the siding. While it's in the siding, the crossing gates open and close. When it's time to leave, you hear the guards whistle, and then the train comes out. We can add all kind of functionality just from this one chip. Something like that. Lift the barrier gates, change the point, wait for a little while, then lower the gates, make the lights go green or the semaphore arm, wait a little while, switch the relay. If you've got the link in, wait till you hit the totty. And if you haven't got the link in, just use the preset time and repeat for the same going right. The code for it, if you look at the JAL SIG group video, is very simple. It's not really a complex program. It does lots of things in the one. Now, I've been cooperating with Fraser to get a PCB done for it. And at the moment, well, let you see it first. That's the PCB. It's not bigger than me, that's not to scale, right? It's something like about roughly 2 inches square. So it's pretty small. Most of the stuff that you see round the sides are actually connections. Up the top, the power coming in. Down the left-hand side, there's the left-hand signal, the left-hand point, the left-hand totty. And down the right-hand side, the right-hand totty, signal, point, etc. And the two auxiliaries. And down the bottom left, there's the relay. So the track controller coming in one end and going out to the track the other end. If this is a bit easier, that's what it will look like. Everything you see in blue, these components are purely connectors. They're probably going to be screw connectors. If we take away the blue connectors and just count how many components on the board, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But 15 components. It's not a big component count. Therefore, we don't expect the cost to be extortionate. But it gives us lots and lots of functionality and options. If you don't want to have, for example, operating the points, these pins will still switch their state, and you can put something else on their place. You decide how to use it. It's essentially a shuttle with control over the journey time and the lights time, with the add-ons of the possibilities of sound and the sequencer points and so on. And how you use it is up to you. At the moment, I've got something like 20 of these on order from China. It won't appear in the journal, in other words, it won't appear in the kit locker until June, because Merck works in mysterious ways. Right? What they do is, I'm going to get these myself, pay out my money, just to test them, and if I'm happy they work, then Martin Perry will order officially in Merck's behalf, and they'll officially make up some test kits that will send for folk to test. And then once that's happened, then they'll appoint an elf to actually create them into kits, and then they'll appear in the kit locker. Yeah, in the meantime, I'll be keeping some of these boards to myself. If anybody wants one to play with, I'm quite happy to share the code and so on with them, and the component list and the circuit diagram in the meantime. I haven't got the price yet for the PCB, but I'm thinking it's probably something like, since there's only a quantity of 20, maybe like 70p a go, so it's not a lot of money to play about with. Right. The other thing that I was remarking to, I think it was to check this, I would make an ideal experimental board if you want to play with JAL. And I know that Fraser's in the JAL SIG group has already got a board he's dedicated for that purpose. But this one has already got on it the regulator, it's already got on it a couple of trimmers, it's already got an output driver, a relay, and lots of pins that you can change to be input or output. All the things you see down the side don't have to do those jobs. You can assign them to something completely different if you're designing a different circuit. It could be a shuffler rather than a shuttle, and so on. It's your choice to learn programming. So all kind of points of view, I think it's a very versatile board. I think it's a versatile kit. And if anybody wants one of these boards, let me know. And at that, I'm quite happy to answer any questions, any comments or suggestions you guys have. Because it's not in its complete stages. If you think of a better idea how to use a particular pin for auxiliary, for example, I'm all ears.